now let us look at a few algebraic rules. Basically the addition, subtraction, multiplication or division of different probability theorems. So a major part of this we had studied in sets and relations as well, where we had learned how we can draw the Venn diagram. Similarly, we are going to do things here. So a few rules that you must always remember are complement of A, complement of probability of A can be written as probability of A dash. Now how do we represent this? I hope you all remember we had studied in sets and relations. If let's say this is my set A and this is my universal, then my complement of A used to be this portion. This portion would become my complement of A. This is my A dash. This is my A. So similarly, we do this thing, and here A plus, since we have probability here, so probability of A plus probability of A dash, which is the complement, this is equal to 1. Here this is probability value, and here as well it is probability value. So complement of A means everything but not A. So that is complement of A. Let us look at another one, which is union. Again, in sets and relations we had studied this. Let's say if there are two sets, and this is our universal, this one has probability PA, this one has probability PB, and this is our A intersection B, and this is our universal, then our union becomes this portion. I hope you all remember we had studied this in sets and relations as well, where there were two different sets with some intersection points, and if we were to find out their union, we used to find it in this way. And here what major thing that we had to remember, how we can write this in words form or algebraic form. We can say that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now why did I subtract A intersection B? Because once when I'm adding probability of A, this intersection portion is getting added once. Now when I'm adding probability of B, this intersection portion gets added once again. So we have to remove it once. That is why we do minus P intersection A, P probability of A intersection B. Now let us look at another rule, which is of intersection. Intersection, we represent this as PA intersection B, and again, if let's say this is our set A, this is our set B, or this is the probabilities functions that we are talking about, this is our universal, this is our probability of A, this is our probability of B. So this here becomes A intersection B. So this portion is our intersection. Now let's say if in the question we were given that these two are disjoint sets. Let's say if we had, let's say, disjoint sets or mutually exclusive, then what does this mean? This means that the two sets are far apart from each other and probability of A intersection B is equal to 0. There is no intersection points between A and B. So you must remember this. Apart from this, there is one more topic that we need to understand, probability of A minus B. This means that we are including the part only of A. If let's say there is the intersection part which used to be in A and B both as well, so we have to remove that as well. So this one is equal to PA minus PA intersection B. So if I was to show this on a Venn diagram, let's say this is my Venn diagram, this is my A, this is my B, this is my A, this is my B. So PA minus B is basically this portion. So what I did is I took PA, the entire probability of A, and I subtracted A intersection B portion. So I would get PA minus B. So this is how this is written. Now let's say if again here A and B would have been disjoint sets, then probability of A minus B would have been 0, because during this, whenever we have disjoint sets, probability of A intersection B is always 0. Now let's say if we were given let's say 3 sets. So again the same concepts that we used, we draw 3 different circles which are overlapping with each other. This is my A, this is my B, this is my C. This becomes my A intersection B, this becomes my B intersection C, and this one here is my A intersection C. This one is A intersection B intersection C. And now let's say if I was to write down P of A union B union C for this type of, let's say, union of 3 probabilities, or again we represent union by or, I hope you all remember, and we represent intersection by and. So just remember these things. How can we write down the PA union B union C? This can be written as PA plus PB plus PC minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C. So what we did here was, first we added A, B, C, all the 3 different sets. Then we subtracted, since A intersection B, A intersection C and B intersection C, these got added 3 times, so we had to subtract it twice. So we removed it 3 times, but what happened was A intersection B intersection C, this middle portion also got subtracted 0 times, so we had to include it as well. So that is why we added it at the last. Now let's look at a question to get our concepts clear about this thing. A, B, C try to hit a target simultaneously but independently. So A, B, C are independent here. Their respective probabilities of hitting the targets is, so that means PA is given to us, that is 3 by 4. PB is given to us, that is 1 by 2. PC is given to us, that is 5 by 8. So the probability that the target is hit by A or B but not by C, that means A or B, that means A union B, but not by C, that means we have to remove C from this. So we have to find out this probability here. Now how can we do this? First, from here, what can we write down about P A union B minus C? Let us draw the Venn diagram for this. Let's say this is my Venn diagram. This is my A, this is my B, this is my C. Now here what I'm talking about is, let's say this is my A, this is my B, this is my C. It should be in A and B but not C. That means this is the portion that we are talking about. So this is the portion. That means none of the portion of C should be included. No, neither the one which is with the intersection with A, nor with B, nor with all 3. So all these 3 parts need to be excluded from A union B. So that is how we write P of A union B minus C. So how can we do that? How can we write this portion in some other way so that we can bring it in this format where we have these variables PA, PB and PC, and then from there we can calculate the value. So what we can write down is, this shaded portion can be written down as P of A union B into P of C complement. I hope you are getting what I'm trying to write here. Or let's say if you're not being able to address this directly, what I'm saying is P A union B minus of P A union B intersection C. So I can write this minus sign in this format, right? So, and this can be written in this format. I hope you are getting what I'm trying to say. What we are doing is, first we are finding out the probability of A union B. That means this entire portion is coming here. This portion is also coming here in A union B. And what we are doing is we are multiplying it. That means we are finding out the intersection with P complement. And what is P complement? This portion is our P complement except for C. So once we take the intersection, again this portion would be removed because this does not come in A union B, and this portion would be removed because this does not come in A union, this does not come in C complement. So only this portion will be left with us. So now we can simply find out the values. PA union B can be written as PA plus PB minus PA intersection B. This entire thing is multiplied by P complement, so this can be written as minus PC. So from here, let us substitute the values. PA, PB. So this is 3 by 4 plus 1 by 2 minus now PA intersection B. That means we are talking about this entire portion. What is A intersection B? It is nothing but the multiplication of PA and PB. I had told you that PA intersection B would be equal to PA into PB if they are independent events. So here we can see that the events are independent. They have mentioned it here. So from here we get this to be 3 by 4 into 1 by 2. And this is multiplied by 1 minus PC, so 1 minus 5 by 8. So what do we, sorry for that, so what do we get our answer to be? It comes out to be 21 by 64. So again, for solving these type of questions, wherever probability of one or more events or A, B, C have been provided to you, it is recommended that you draw the Venn diagram. This type of diagram, this is known as our Venn diagram. And once you draw the Venn diagram, you will be able to find out the answer very easily, because you can at least find out the part which is shaded. You can write that in equation form in different ways. So after you write down the equation in different ways, it becomes very easy for you to just substitute the values and find out the answer. Now let's look at a few more points. Mutually exclusive events. Again, mutually exclusive events, also known as disjoint events. This is also known as disjoint events. What is this? Let's say if I have A set, this is my B set. So they have no intersection point among them. So probability of A intersection B is always equal to phi or equal to 0. So there is no intersection point. That is why we say they are mutually exclusive or disjoint events. Now exhaustive events. Exhaustive events means that all the set of events make the sample space. That means what we are saying is, let's say if there are events such as E1, E2, E3, E4 up till En, there are n number of events occurring. Now we are saying that all these events, if combined in a set, if taken the union, that would form our sample space. So we are saying E1 union E2 union E3 union E4 up till En, this is equal to our sample space. So this is how we write down our exhaustive events. Now conditional probability. Conditional probability means that a probability of an event occurring given that one of the other events has already occurred. So let us look at the formula here. This is the formula here of conditional probability. We say that probability of A given that B has occurred is equal to P of A intersection B upon probability of B. So here we are assuming that B has already occurred, and we are saying that A is the event of which probability we are finding. So probability of it occurring. This would be probability of this event occurring. So this is our A. Again, you have to remember this. Let us look at a question to get clear about this thing. Let's say a card is picked at random from 52 playing cards. So our total outcomes are of course 52. Given that the picked card is an ace, so what we can say here is that B is ace. We've already picked up B, which is our ace. The probability of this card being a spade. So A is, we are saying that what would be the probability of this card being a spade. So how do we write down P of A given that B has occurred? This is written as PA intersection B upon PB. Or for this scenario, what we can write down is P, let's say probability of the card that we've drawn, it being spade, given that the card picked is an ace, this would be equal to P A intersection B. That means it must be a spade as well as it must be an ace. So what can be the probability of it being an ace and a spade? So in our pack of cards, spades are 13. Out of those 13, how many are aces? There is just one ace, right? So that means P A intersection B. That means we are saying that the picked card should be an ace and it should be of spades. That means it should satisfy both the conditions. It should be a spade as well as it should be an ace. So it can be only one card. So the probability comes out to be 1 by 52. This is for A intersection B that we are finding out. Now probability of B. Probability of us picking an ace. How many aces are there? There are in total 4 aces. So we say our probability becomes 4 by 52. So ultimately this is 1 by 4. This is our answer. So I hope you understood how we are finding this. A intersection B, that means A should have also occurred and B should also have occurred. What would be the probability of both of these occurring together? So that is why we came up with this probability 1 by 52, because ace and spade occurring together, that means there is just one card which can satisfy this condition, and of course their the total possible outcomes are 52, and it is the probability. So 1 by 52 becomes our probability of A intersection B, and probability of B, that means of us picking an ace. There are 4 aces, so it becomes 4 by 52. And upon solving this, we get our final answer, which is 1 by 4. Let's look at one more question. If A and B are any two events such that PA is equals to 2 by 5 and PA intersection B is equals to 3 by 20, then the conditional probability, so whenever conditional probability is given, try to write down its equation and try to simplify it in the most simplest way you can, so that you can simply just substitute the values and find the answer. So here we have to find out the probability of A, given that A complement union B complement has already occurred. So this would become P A intersection A complement union B complement upon P A complement union B complement. So in this type of case, what we can do is, first let us try to understand this by again drawing a Venn diagram. I had told you, whenever you see such type of questions, it is recommended that you draw a Venn diagram. You draw this diagram, this is our A, this is our B. Now let us try to understand this A complement union B complement. A complement means the portion all except A, and B complement means the portion all except B. That means if we remove A, what are the portion that we are highlighting? We are highlighting this portion, and since it is a union, that means it will be everything. And now they have told us that it is union with B complement. So B, what is B complement? Again, it is everything. So basically our A complement union B complement is an entire universal space that we are talking about. So that is how we can visualize this A complement union B complement. Now let us try to convert this into a more simpler form. I hope you all remember in sets we had studied if A intersection anything inside the bracket is given. So we can write this down as A intersection A complement union A intersection B complement. And this remains as it is, P of A complement union B complement. So from here what do we get? A intersection A complement. This is of course phi. So phi union anything is anything. So what we have? Probability of A intersection B complement upon P of A complement union B complement. So from here, what can we write this equation to be? This becomes PA minus P A intersection B. PA intersection B complement. So A intersection with B complement. What does that portion come out to be? It comes out to be only this portion. That means this can be written as PA minus PA intersection B. And how can we write down PA complement union B complement? How can this be written? This can be written as simply 1 minus P of A intersection B. we simply are not including the portion that is in the intersection. That is what we mean by A complement union B complement, right? So now we've gotten simplified this into the most simplest version. Now let us put the values and find out our answer. I'm doing this here. PA is again 2 by 5 minus PA intersection B becomes 3 by 20 upon 1 minus 3 by 20. So from here, what do we get our answer to be? 5 by 17. This is our answer. So I hope you are understanding how we are writing all these values. Again, it is recommended that you draw the Venn diagram so that you can at least visualize what they are trying to ask us and what is it that we have to find and what are the information that we have been provided with. Now we will be looking into a further more advanced version of this conditional probability, which is known as the multiplication theorem.